Hello. Welcome back to another video. Today we are discussing how to factor trinomials, specifically when a is greater than 1. Now this method, borrow from brother, has a numerous amount of different names. I try to find out like the consistency on the name. Some may call it cherry picking. I think that's the biggest one I've seen so far. And there's really just some out there names. I'll just say that. But really, I really like this method. Um, it's not as helpful during like when you have four terms. So once you start getting into cubics, it doesn't really come too much of a help. But it's great for quadratics right now, especially when you have, let me see here, especially when you have values that are greater than 1 for your a. And as a reminder, ax squared plus bx plus c is our standard form. So really the premise behind this, behind Borrow from Brother, is I always like to set up this narrative of you just hate when your a value is bigger than 1. Like you just hate that so much. And you just want to go back to good old days when your a value was just the value of 1. That was nice. That was simple. And that was pretty easy. So let's go back to that. Let's force our equation to go back to a value of a equals 1, but you may be thinking to yourself, I can't do that. I mean, that's like illegal. I mean, look at that. There's a 2 right there in front of my x squared. So that's stopping me from having a value of 1. Okay, so get rid of it. And that's like the narrative I always set up with Borrow from Brother. But that's essentially what I kind of want to do. Here, I'm going to quote unquote get rid of that 2. So I'm going to multiply that 2. Ooh, that's bad. I'm going to multiply that 2 times my c value. Again, what I'm essentially doing is a times c. Okay? So a times c would be just 10. And I'm going to replace that c value with that 10. So instead of saying 2x squared plus 11x plus 5, I'm now saying x squared plus 11x plus 10. Again, I multiplied my a times my c, and I literally wrote it like that. And actually, this is not too bad. I mean, this becomes a little bit more bearable for us. Because if I just gave you this question alone, x squared plus 11x plus 10, and I told you to factor it, well, you would find the factors of 10. Okay, cool. So two numbers that multiply to be 10. We got 1 and 10, and 2 and 5. And that's it. And what are we looking for here? Two numbers when you multiply, that is not very spacious. Two numbers when you multiply to get you 10, and when you add, get you 11. So within those two pairs, it would have to be 1 and 10, because 1 times 10 is 10, and 1 plus 10 is 11. So if I had that equation there, I told you to rewrite it. I would put x plus 1 and x plus 10. See, that's not too bad, right? Whenever your value of a is just 1, things are nice, things are simple. I mean, look at that grouping video. That was a lot of work. But you can't just multiply by 2 just because you want to. That first step, just because I wanted to get rid of it, I multiply by 2. I probably can't do that. Probably mathematics says something that's wrong about that. And mathematics does say something that's wrong about that. So instead of, we probably should, I guess, reverse our error or reduce our error. So here what I'm going to do is instead of multiplying by 2, let me divide by 2. Again, instead of multiplying by 2 like it did in the beginning, let me kind of cancel that out, quote unquote, by dividing by 2. So when I do that here, notice I'm only dividing the numbers. So x plus, 10 divided by 2 is just 5. So that'd be x plus 5. And 1 divided by 2 is that's a decimal. We tend to not like decimals. And we tend to not like fractions. So how about we get rid of that fraction? I know you're probably rejoicing in your seat when I said that. Let's remove that fraction. Again, this is where this can be kind of confusing. since I tried to reduce this 1 over 2, and I didn't get a nice whole number at the end, what I'm going to do is I'm going to take that 2, and I'm going to bring it out front. And I will now rewrite it as 2x plus 1. Again, I took that 2 that was in the denominator, and I kicked it out front of the x. Notice, for this other one, I did not do that, because 10 divided by 2 got me 5, a nice whole number. But if I tried to do this here, 1 divided by 2 was a 0.5, which is not a whole number. So I kicked that 2 out front. So maybe think to yourself, that was kind of weird, right? Like, how do I know if he's right? How do I know if this is actually correct? We'll prove it. How do I know if that's correct? We'll prove it. I won't do this proof for all the other ones just because I want to be diligent about time. But to prove it, we just apply the distributive property. You may remember a thing called FOIL, or maybe Punnett square or box method or whatever. Same thing applies here. So 2x plus 1 times x plus 5, all you're essentially doing is multiplying each term by all the other terms. So 2x times x would be just 2x squared. 2x times 5 would be 10x. 1 times x is just, it's 1x, but I'll just say x. And then 1 times 5 is just 5. And then here we're like, oh, I can combine those middle terms. So this would be 2x squared plus 11x plus 5. And hey, is that the same equation we started with? It is. It is. So I'll do like a little check mark. So that's good. Now, some people argue that I committed, how do I say this? I committed some mathematical errors by multiplying my a times my c in the beginning and then just dividing by that a value in the beginning as well. This is, I guess, how do I say this? I guess you could say this is a shortcut that works every single time. It works whenever you have a quadratic. Again, once again, it's a cubic, kind of just falls apart, essentially. But for quadratics, it is great, it is awesome, and it is nice. So 3x squared plus 10x plus 8, I hate that we have a 3 there. I want to get rid of it. So I'm going to get rid of it. A times c, oh my gosh, a times c is going to be 3 times 8, which is 24. And so what I'm going to say now is I want to get rid of that 3. X squared plus 10x plus 24. Again, just multiply that 3 times 8. Cool. I like this now. I feel comfortable with this. This isn't too bad. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Sweet. I'm looking for, two numbers when you multiply to be 24, and when you add them to give me 10. Oh, that's not bad. Because as I go through all my combos, I'm like, okay, 1 plus 24 is 25. That's clearly not 10. 2 plus 12 is 14. Oh, wait, 12 minus 2 is 10. That might work. So let me keep going. Okay, 3 plus 8 is 11. 8 minus 3 is 5. That won't work. Oh, 4 plus 6 is 10. So we got 2 possible combinations here. We can either say 4 and 6, which works, or we can say 12 and negative 2. So let's make sure that they meet both conditions. So 12 plus negative 2 is positive 10. Okay, cool. Ooh, 12 times negative 2. What is that? That would be negative 24. So it actually wouldn't work there. But do not fear, because 4 plus 6 is 10, and 4 times 6 is 24, which leads me to say here that x plus 4 and x plus 6 would be my trinomials. Now you're thinking, I multiply by 3, and that seemed kind of fishy. So let me backtrack a little bit. And instead of multiplying by 3, let me divide by 3. So I'm going to divide my numbers by 3. Okay, so that second part there, 6 divided by 3, that's not bad, because 6 divided by 3 is just 2. 4 divided by 3, that's like 1.3 repeating. I don't like decimals, and I don't want to keep that as a fraction, and I can't reduce that fraction anymore. So what we're going to do, we're going to kick it out front. So take that 3 and kick it out front. 3x plus 4. Again, wow, that's embarrassing. Again, I'm not going to prove this just because I want to be diligent about time. And if you want to prove it, you would just have to multiply these two binomials together. Get some water. If you're following along in your notes, be sure to try this one by yourself. So if you need to pause the video, go ahead and pause the video. Borrow from brother tells us narrative of me going back to the good old times where my a value was just 1. So to get rid of this 2, I'm going to multiply it by my c term, which would be 40. So instead of saying 2x squared plus 13x plus 20, I'm going to end up saying x squared plus 13x plus 40. Now this is good. This is nice. This seems a lot more doable. I'll say that. Here we get two numbers that multiply to be 40, so this isn't too bad. 1 and 40, 2 and 20, 4 and 10, was that 5 and 8, and then 6, oh, my bad. And then actually that would be it. I was going to write 6 and 4 for some reason. I'm not sure why I was going to, but it won't let me scratch it out. That's weird. Okay. So here, 1 and 40, 2 and 20, 4 and 10, 5 and 8. I need to find two numbers when I multiply. That's not enough space. They equal 40. And two numbers when you add to get you 13. We got 4 pairs. So let's test all 4 pairs. So with the first pair, 1 and 40. Well, 1 plus 40 is 41. And 1 minus 40 is negative 39. So that won't work. 2 and 20 is 22 or 18. 4 and 10 is 14 or 6. Oh, 5 and 8. 5 plus 8 is 13. And 5 times 8 is 40. Hey, so that means here, instead of writing x squared plus 13x plus 40, I can rewrite that as x plus 5 and x plus 8. Again, it seemed kind of weird that I multiplied by 2 in the first place. So let me kind of reverse my actions by dividing by 2. Oh, okay, that's not bad because 8 divided by 2 is just 4. 5 divided by 2. Got a decimal. We don't like decimals, and that's a fraction. I can't reduce that fraction anymore. So again, once you have this situation, kick that 2 out front, and then we're getting 2x plus 5. Notice again, if I wanted to, I could multiply those two binomials together. And after I multiply those two binomials together, we would end up getting our answer of 2x squared plus 13x plus 20. So in this case, we have our binomials of 2x plus 5 and x plus 4. Final expression here that we're solving by factoring. We're not solving, we're factoring. 5x squared plus 23x plus 12. I don't like that 5, so I'm going to get rid of it. How do I get rid of it? By multiplying the 5 by the 12. Well, 5 times 12 is 60. I'll do 8 times c. And so here, x squared plus 23x plus 60. Hey, that's not bad. I feel confident on that. So here, we'll have, I think, like 6 pairs. 5 and 12, 6 and 10. And that will be it. Not sure why I'm hesitating there for a second. But that'll be it. So we have 1 and 60, 2 and 30, 3 and 20, 4 and 15 as well. I don't want to. I'll just rewrite it. That's fine. I was like, man, I thought we had 6 pairs. We do have 6 pairs. See here, 4 and 15, 5 and 12, and 6 and 10. Perfect. That's better. But what are we looking for? We don't want all 6 of those. We want 2 numbers that when you multiply get you 60, and when you add get you 23. So let's start eliminating. Okay. 1 plus 60 is 61, or 59. We got 2 plus 30, which is 32, or 28. 3 plus 20 is 23. Okay, that might work. Let me check the other ones just to be safe. 4 plus 15, oh, that's 19, or 11. 5 plus 12 is 17, or 7. And then 6 plus 10 is 16, or 4. So it looks like here, 3 to 20 works, because 3 plus 20 is 23, and 3 times 20 is 60. So with this expression here, what I can, oh, that's not good. What I could do now is rewrite this as x plus 3 and x plus 20. And I'm like, well, hold up. I multiplied by 5 in the beginning. Is this even legitimate? Okay, so let me divide by 5 to appease the crowd, I guess. Perfect. So when I divide by 5 here, this isn't too bad because I have this second term as x plus 4. 20 divided by 5 is 4. Ooh, 3/5 fraction. I'm freaking out, but don't freak out, because if you have a fraction and you can't simplify it anymore, take that number and boot it out front. So we end up getting 5x plus 3. And I'm going to box up my answer because I like doing that. Bar from brother works great. It doesn't take too much time, as you can see in this video link, and it's a great little tool that helps you kind of understand a little more what's happening in quadratics. Now, again, this will not work for cubics. So when you have to factor cubic trinomials, this will not help you. It just won't. But it's great for quadratics where a is bigger than 1. If you have any questions, please let me know. If not, y'all have a great rest of your day.